Classes.
Yeah.
Hey class. Ian.
Hey class. Hey class. Ian here.
It's for anyone, like, yeah, it's for anyone that misses my class. And then whatever, they're going to have to wade through like 38 minutes of screencasts
Ian Henry Vieta.
and annoying things.
That's me.
Rather than me just like sitting down doing it, but whatever. All right, 6.1. All right, multivariable linear systems and raw operations. How many of you guys have solved systems of equations before? Heck yeah, you have, because you did algebra 2. Yeah, to in this class. All right. So solving systems of linear equations, that's the whole goal. That's what we're going to be working on. That's where you can use matrices. One of the people in my other class asked me like where I've actually used matrices before in my life, which is a good question. I'll take a hot 30 seconds to talk about where every single one of you uses a matrix. I'm gonna guess 75% of you use it every day, if not multiple times a day. How many of you guys have a smartphone? Okay, if your hand isn't raised, I know you're lying. Okay. And how many of you guys take a photo, every day, either on Snapchat or Instagram, whatever? Okay, cool. So exactly, my prediction came true. I'm Nostradamus. I'm a psychic. Look at you using that camera. Do you know how your camera works?
Matrices.
Aha, it's a matrice. But you're like, what the heck? What? How? So imagine a bucket collecting drops of water. Not necessary. I'm trying to explain something cool, even though it's gonna waste my time. All right, so imagine a bucket collecting water, right? Okay, cool. Now imagine like having 1,000 buckets by 1,000 buckets. Literally, lots and lots of buckets, right? It's literally it's like tons of rows and columns of them. Can you guys imagine this, like, just like rows and rows and rows of buckets? Okay. But instead of collecting water, every single bucket is collecting photons, packets of light. That's how your camera works. Because unlike old times where there's literally film, and then you have the light go onto the film, it's literally the photons are reacting with the chemicals on the film. We now have digital cameras, which have CCDs, which stands for charge coupling device, because these buckets and buckets are literally collectors of light, collecting photons. So if you take a photo and you look at the data behind the photo, it's literally going to be a bunch of like zeros and ones. It's going to tell you exactly how many photons are in each pixel and et cetera, et cetera. Yeah, so I used that when I was doing my undergraduate thesis. Had every single photo of this star, like I collected how much light it was. And over the course of a night, it would change in brightness because it was a variable star. It would change the brightness. Literally variable stars varying its brightness. And so I could prove like the period, how often, like, okay, it pulses every 2 days, it goes brighter and dimmer. This is the majority of the time, this is how we find exoplanets. We look at a star, we take lots and lots of photos, we compare the photos against each other, right? We stack them on top of each other. So I have this matrix, which is a single photo describing how bright every single pixel is. I stack them on each other, and I can make a movie according to time, having it like be brighter and not. So this is how we find exoplanets. We say, oh, hey, look, all of a sudden we had a dip in brightness. This exoplanet went across. So that's just one way. But yeah, your cameras and your phone, use that. Now you know. Oompa. All right, let's keep going.
I'm sorry, that just had to happen.
You set it up.
No.
You're welcome. Okay, so just at the shot. All right, a Gaussian elimination. First way we're going to solve systems of linear equations is a Gaussian elimination. How many of you guys have heard of Gauss? Like a Gauss? A Gauss? No. Ooh, okay. He was a famous mathematician. He's really big in stats and math and physics. Like literally, if you ever take electromagnetism, electricity, magnetism, you're going to deal with Gauss because he was brilliant. What I just said?
You said he did that. You didn't say what.
Yeah, so Gaussian distribution in statistics is like the way the data is distributed. So as a senior, you should have known because it was in the video, like, oh, hey, look at this distribution. That's one way. Another way is, talks about the flux. through a certain area. So like how much charge is going through a certain area per time. Yeah, lots of math stuff. Cool. Okay, so the Gaussian elimination is a way we deal with matrices. It's a multivariable linear system. Hold on, multivariable means more than one variable. So we might have an x, we might have a y, and we might have a z. We might have 3 variables, multivariable. All right, so it's a system of linear equations in 2 or more variables using a substitution or elimination methods. It's possible to convert the multivariable linear system into an equivalent system in triangular form or row echelon form. This process is called Gaussian elimination. So a couple things to notice. On the left side, so let's see, let's write this. So on the left side, equations form a triangle. Do you see this? No, we don't. Do you see the triangle? Okay. And the leading coefficient is 1. So on the left side, the leading coefficient is 1. What do I mean when I say leading coefficient? Like, check it out. There's a 4 in front of the z. On the second line, there's a 4 in front of the z. That leading coefficient, that coefficient's not 1, but the leading one, aka the first coefficient, the first one we run into. So this is a coefficient of 1 in front of the x, in front of y, in front of z.
Oh, right here.
Wait, I don't get
Wonder
it.
who
No
stole it.
way. You get to the rescue.
The coefficient?
Yeah.
What's the coefficient for x in the first line?
Oh, 1.
Okay, what's the coefficient for y in the second line? What's the coefficient of z in the third line?
1.
Okay, so all the leading coefficients are 1. The leading is the first one.
Oh, yeah. Well, I already
That's
did
it. Yeah, well, just, there we go. Here we go.
Yeah.
And notice, the last equation only has 1 variable.
So can't you just plug in -2?
The last equation only has 1 variable.
Okay.
Awesome. Okay. So this is row echelon form. Yeah, it's super easy to solve because if I know the value of z, go up to the previous line, plug that in, solve for y. Okay, now I know z and y. Go to the first ones, plug it in. Cool. That's all work. I could show you ways to do it that won't take as long. And that's how it's like the basics of what we're going to do with matrices. So there's a thing called Gaussian elimination. I'm going to call it an algorithm. What does an algorithm mean? How many of you guys are in AP Comp Sci right now? Okay. 2 days. 2 days of the whole year, and it's just the last 2 days. Surprise, surprise, computer science has matrices in it. I just did this whole rant about... Yeah, so what is algorithm? What algorithms have you learned?
What? Can you give us a hint?
Did like...
Algorithm?
Do... So, maybe like search, sort...
What?
No? Not familiar?
They didn't do that yet.
Have you done... Okay. Cool. Okay. Yeah. Okay. So it's an algorithm. Do we have an idea? Okay. So an algorithm, I think of it like a recipe. It's literally a set of directions. Set of directions. So it's a method, right? So for instance, I have an algorithm to bake a cake. How do you bake a cake? Okay, you measure exactly 2 cups of flour. Then you beat the eggs. Then you put in the blah, 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 right? So it's literally a ordered, like, exact set of directions. You don't beat the eggs before you put in the flour, like, whatever, right? So you don't go out of order. The algorithm is very specific. You go and do it in order. All right, so it's a set of directions. It's kind of like, okay, so to leave school, I'm on the 2nd floor. I need to reverse, turn left, turn left, turn left, turn right. But it would be really stupid of me to turn right first and then turn left and left. Like, where am I going? Into a wall? No. So you have to do it in order. This row echelon form, Gaussian elimination, you have to do it in order. Okay, we got it. Operations that produce equivalent systems. Each of the following operations produce an equivalent system of linear equations, interchanging any 2 equations, multiplying one of them by a non-real 0 number, adding a multiple of one equation to another. those are fine. We produce equivalent systems. So these are like our tools. Imagine you're like a carpenter with like a tool belt. You know what I'm talking about? Like literally a belt with tools on it. Okay. Looking lost. We're looking lost here. So these are the tools in your toolbox. The first one, interchanging any two equations. Oh, I see z is equal to this. Let me plug it in other places. Multiplying one of them by a non-real zero number. You did this in algebra 2. Remember how we like solve two equations, like we graph them, we add them together, substitute elimination?
Yeah.
So that's something you can do. You can multiply a whole equation, like, oh, I'm going to multiply everything by 2. As long as you multiply both sides by 2, you're okay. And then you also can add a multiple of one equation to another. So maybe I'll add 2, like, this is what we did when we were doing elimination. This is literally what we did. Oh, multiply the first one by 3, the second one by 2. When you add them, some of them will go away. Okay. So you've done this before. It's just a lot of, like, English right now. All right, but our goal of doing this, our goal is to write the system in triangle form, aka row echelon form. So that triangle was called row echelon. All right, so this is the algorithm. This is like this is your recipe. You have to follow it exactly. If you don't bake a cake exactly correctly, it's gonna be blah.
But I don't think that's true though. You could do the things out of order.
Okay, so yeah, it may be like food that's fit for like a horse to eat, but not human, right? So in order to have like the perfect cake, you must follow these directions exactly. In order to do row echelon form, you have to follow these directions exactly. You have to do an order. All right, eliminate the x term in equation 3 by replacing equation 3 with the sum of the multiples of equation 2 in another equation.
Like that's like
So we're gonna go through the example, but like
it's like explaining it.
I'm going to constantly refer back to this. So when I'm like reading blah blah blah, this is what I'm referring back to. So we're gonna go through example 1 first, and we'll go through how to do it. Did that give you a whole page for this?
Yeah.
Okay. Yeah. Welcome to 6.1. We're doing 6.1 today. Great. Okay. All right. Poor Nathan. Nope, you can definitely. If you can hear my cat meowing in the other room, you can hear you wolfing. Yes. 13 minutes into it.
You're screencasting right
Exactly, because normally when I make screencasts, I'll go back and edit it out. Yes. Exactly, because I go back and I edit it out.
now? You cut out all the side shots.
I cut out. I'm not cutting this out.
Why?
No, this is a waste of my time. I'm done making screencasts where it's just me. It's going to be class from now on. Whoever wants screencasts, this is what it is. If Nathan's gone, he'll watch it. Like right now, Ian is MIA, and he'll watch whatever he missed. Cool. Whatever. This is the screencast for lesson. Yeah. It's just like the more side chatter, the worse it is, the longer it is.
Look, Ian's gonna remember this when he watches all the screencasts. Ian, you're being recorded right now.
Wait, is your cat as far away as I am? Like, where's your cat?
In my bedroom.
Like, how far away is your bedroom from when you're?
Let's think about the loudness of my cat versus the loudness of you.
We don't know.
Yeah.
How many cats do you have?
1.
How loud?
Okay. Right, not loud. That's my point. Okay, so let's go through this. So, example 1, poor Nathan. Write the system of equations in triangular form using Gaussian elimination, then solve. So, let's rewrite the directions. Like, what is this actually wanting from me? Step 1, write in triangle form. Step 2, solve. There's literally like 2 things we have to do. First, write in triangle form, then solve. So let's go through. I'm gonna call this. Okay,
But what are we solving for, X?
X, Y, and Z. I'm solving for 3.
So what do you need to find the read?
There's there's one triangle, but I'm solving for the value for X, Y, and Z. There's 3 values I'll find. Okay. So turn back to the previous page where there was a triangle that I made.
Just like that triangle.
That's exactly what we want to do. Okay. So I'm going to label this first one as E1. I'm going to label this one as E2 and label this one as E3.
For echelon.
Yes. Because if you look at the algorithm, the recipe for this, this is equation 1 is the top one, equation 3 is the bottom one. So these are my equations. The top one's my first equation. That's why I named it E1, equation 1. Okay, so let's go do step 1.
But I thought the last one's supposed to have one variable.
It is supposed to have one variable. So we have to go through this 4-step process to make it be in one variable on the last. To make it into that row echelon. The row echelon's where it only has one variable at the bottom.
That's what we're solving.
This is we're gonna make the triangle, and then we'll go back and like solve for the stuff. Okay. So step 1. What did step 1 say? What did number 1 say from the previous page?
That's you. That's you.
Equation 3.
Thank you.
In equation 3.
Make the leading coefficient 1.
Equation 3 with the start of it. I don't know what that means.
Okay, so first thing I'm gonna do is make the leading coefficient in equation 1 by in equation 1, I'm gonna make it 1 by multiplying. Oh my gosh. Multiplying the equation by what?
Make leading coefficient in equation 1. What?
Make the leading coefficient in equation 1. Make the coefficient 1 by multiplying the whole equation by the exactly by multiplying by the reciprocal. What's wrong? All right, just a friendly reminder. I'm a broken record. Your phone should be not on your desk, not in your pocket. It's so far into your bag that if it buzzes, you won't even notice. All right. Eliminate the temptation. All right, make the leading coefficient of the first equation 1 by multiplying the whole equation by the reciprocal of the leading coefficient. Okay, so in equation 1, what's my leading coefficient right now?
5.
So I have to multiply every single thing by? Yep, I'm going to take equation 1, multiply by 1/5. All right, so 1/5 times 5x minus 5y minus 5z equals 35. So multiplying every single thing by 1/5 gives me x minus y minus z equals 7. So I'm going to rewrite the whole like the whole thing now underneath. I'm going to write equation 2 and 3 underneath. That way I can see.
Will it always be the same leading coefficient for all terms?
Well, we want all of the leading coefficients to be 1.
But what if it start off like they all happen to start off 5, so we got lucky. What if it's 5x minus 3y minus 2?
Oh, you'll have some fractions.
Really?
Yep.
So you're gonna have
So it has to be less than 1.
You have different reciprocals.
Wait, if the coefficient of the first thing in the first equation.
Thing, got it. So just x basically.
So I only took the thing for 5x. Imagine if there wasn't a 5 on the y and z. Cool. Maybe it was a 4. You'd have 4/5 of them, like whatever.
Jenna, I had that exact same question and I was really about to ask.
We're in sync here.
Congrats.
Wow, none of us.
Wait, what are you doing?
Rewriting the whole thing.
No.
Just so I could see, I changed my first equation, so now I'm showing you the matrix how it is now, the system of equations as it is now, because I multiplied the whole top equation by 1/5, so now it's different a little bit.
Are you
you mean control things on Matrix?
on the other page?
We're literally following the directions from the previous page, going through and making the triangle. Wow. Okay. So, because the first thing is I have to eliminate the x term in equation 3 by replacing equation 3 with the sum of multiples of equation to another equation. Okay, so we're still working on that number 1.
Really?
Yep, unfortunately. So, the second step that I'm going to do here, because I'm still trying to get that dang first step, right? So now, what I can do is eliminate the x term in equation 3 by replacing it with 2 times equation 2 plus equation 1. Okay, so I'll go through that a little slower. I'll write what I'm saying.
This number 2? Step 2?
Yep, that's what I have 2 circled for. Step 2, eliminate. Sorry, that came out
No, because you said we're still on step
worse.
1, and then that's why I was asking, because you said we're on step 1.
Yeah, we're on step 1 of the previous page. Okay, so we are still trying to do this.
This is so long.
So that's why I'm saying why
Okay,
did
cool. I don't know why you want me to do it that fact. Nice. I'm going slow so you can understand every step, but then we will speed up because you'll understand how to do it. I'm still trying to eliminate the x term in equation 3. Still trying to eliminate x term in equation 3.
So that's why I'm saying, are we on number 2 or number 1?
We're still trying to eliminate the x term in equation 3.
Oh, so we're in the second part of number 1.
Yep. Maybe I should make this like 1a and 1b. Like 1a, blah, blah, blah. 1b, eliminate the x term. What? No. Oh.
Yeah, I wasn't talking about yes, I don't know.
Eliminate x term in equation 3 by replacing with, how should I do this? Do you have any idea? Let's see.
It's 2 times 7, that's wrong
3 times equation 2 plus equation 3. So I can get rid of the bottom x by adding 3 times equation 2. So this is where my equation 3 is, equation 2, equation 1. Because what's going to happen to the x terms if I multiply equation 2 by 3 and then add equation 2 and 3?
By replacing what? As we can multiply.
Okay, so what I mean is I'm going to do 3 times equation 2 and I'm going to add it to the third equation. What this looks like is I'm going to take equation 2 and multiply by 3. So I have negative 3x plus 6y minus 9z equals negative 36. So that is, this whole thing right here is 3 times equation 2.
Isn't it negative 12 times 2?
Times 3? Times 3.
Yeah.
Okay, and then I'm going to add it to equation 3. Equation 3 was 3x minus 2y plus 7z equals 30. We add these together. Notice the x's go away.
What is 3e2 plus e3? What kind of equation is that?
Which part?
The part where you say in the box 3e plus sorry, 3e2 and then plus e3.
3 times the second equation plus the third equation.
Oh, that's just the direction?
Yep.
Oh, okay.
That's 4y minus
Wait, 3 times the second equation plus, just plus the third equation. No, like times the third equation.
Exactly.
So
Okay, cool.
that's the first.
So now, wait, hold on. So I'm going to write x minus y minus z equals 7. Let's see. Okay. Negative x plus 2y minus 3z. I'm running out of room. I shouldn't have done that. Maybe 12. And then this is where the, should have wrote it smaller. 4. I'm trying to make it nice and clear for you. 4y minus 2z equals negative 6. I'm going to rewrite them so that way it's all like in a row, in a nice little column.
So that's our new E3.
Yep. Okay. Okay, so we have our new, we replaced E3 with what we have now. E3 is E2, E1. Because going back to the previous page, What's wrong? Going back to the previous page, what it said, to write a system of equations in triangle form, the step 1 of Gaussian elimination is eliminating the x term in the third equation. Did we do that? Yes. How did we do it? With the sum of the multiples from equation 2 and another equation. Now, so I'll go back up and guess what? I'm done with 1. Check that one off. I'm done with it. Now I have to go on to step 2. It's gonna be a little easier now. It's gonna be a little easier. Eliminate the x term in equation 2 by replacing equation 2 with the sum of multiples of equation 3 in another equation. Okay, what does that look like? Let's see. All right, so step 3, the third thing I want to do. Make triangle. Not quite. Step 3. All right, we want to eliminate the x term in the second equation. So when I say number 3, like I'm showing you what?
Me number 2.
Yeah, I'm eliminating the x.
Yeah.
I see how it's confusing, but
She just put the difference. It's the same.
eliminate the x term in E2, the second equation, by replacing E2 trying to reduce the confusion, but it's not working. Okay. We're going to eliminate the x term in the second equation by replacing the second equation with the sum of the first and second equation. Heck yeah, we can. Let's see what happens. Yeah. Exactly. Because if I just add them, guess what? They'll cancel out. Yeah, no?
Yeah.
Okay, if I do E1 plus E2, this is going to be x minus y minus z equals 7, not necessary. Negative x plus 2y minus 3z equals negative 12. So if I just add these together, the x's go away. I have y minus 4z equals negative 5. So that's going to replace equation 2. Alright, so I'll rewrite these. X minus y minus z equals 7 is my equation 1. The y minus 4z equals negative 5 is my equation 2. And my equation 3 is 4y minus 2z equals negative 6. That's my equation 3. What's happening here? What do you notice from the first time we saw the equations till now? Like, what do we see is happening?
Condensing.
They're condensing. It's getting smaller. We're getting more into triangular form. So without looking at the directions, like what's the last thing we really have left to do? So get rid of the 4y in the bottom. Because otherwise equation 1 is good to roll. Like look, I have x as the first and the leading coefficient's 1. E2 is good to go. I have y as the first and the coefficient is 1 as well.
Wait, so how do you know what the goal is supposed to be?
So the goal, is what we said at the top, is we want to write in triangle form and then we want to solve for what x, y, and z are. Because it said,
Okay, never mind.
because it said Gaussian elimination in triangle form. Yep. Okay, we're getting close to the end. We are. I mean, it looks like we're not, but we are. We are.
Wait, but how, like, what were you saying about, like, oh, it's like one coefficient?
So what's the coefficient for the x in equation 1?
1.
What's the coefficient for y in equation 2?
Oh,
1.
Okay. But you
Literally the only thing I have left to do to make it a triangle is
find, like,
figure out the third equation. I have to make,
equals something.
I have to get rid of the y and get z with a coefficient of 1.
Okay.
Okay. All right. So if I go back up to the top, eliminate the x term in equation 2 by replacing equation 2 with the sum of multiples of equation 3 and another. Okay, yeah, heck yeah, I did that. Right? We eliminated the x term in equation 2. We did that. There's no x in equation 2 anymore. Look, there's no x in equation 2, so now we're on the third step. Third step, eliminate the y term in equation 3 by replacing equation 3 with the sum of multiples from equation 3 and another equation. Okay, it just takes a couple times of like going through this for you to see a pattern. Literally, algorithms are like a pattern as well as a recipe. You're doing certain things over and over again, but you're being very specific and direct with like only one way to do it. Okay. Fourth step, we're going to eliminate the y term in equation 3.
Multiply by the equal 4 or something.
So we're going to replace E3, let's see, by replacing E3 with, okay, so in the directions, it says the sum of multiples of equation 3 and another equation. So literally, I want to use another equation. Maybe I'll have to multiply the other equation by something. Maybe I'll multiply the third equation by something. But when I add them, I want the y's to go away. Right, I want to use equation 2, because if I do something with equation 1, I'll get an x back in there. I don't want that. So I'm going to use equation 2. So I'm going to add equation 2 and equation 3 together, but something has to be a multiple. If I add equation 2 with equation 3, I'll get, oh, 5y. What do I need to multiply equation 2 by in order for the y's to go away?
Negative 4.
Negative 4, okay. Negative 4, multiply by negative 4. Perfect. All right, so that's exactly what we're going to do. I'm going to do negative 4 times the second equation plus the third equation. So looking at the second equation, I'm going to multiply everything by negative 4. You guys know you only get 3 bathroom passes per semester, right? Okay.
Did I use all mine yet?
Yes. I have to look. I know you did. Use one yesterday, use one today.
I didn't use one yesterday.
Is it
What if you have a medical condition?
Then I literally have a talk with your dean and I see that, like, yep, you do have a note from your doctor or something like that.
I can get one.
Cool. Okay.
Wait, Miss O'Brien?
If you're tardy, you lose half participation points for the day. If you're a bathroom pass, every single one over 3 is going to be 2 points participation.
Tardy, the rule was like if they come 3 times, then that's when you lose participation. Like, isn't that?
3, no, it's not.
Wait, every time you're
It's not at all.
Well,
It's
which
3
is that it
absences.
adds up.
3 absences. You have excused 3 excused absences per.
What about tardy?
And 2 tardy.
No, no
Like,
absence.
okay,
What
what's your-
happens if you use over 3 bathroom passes?
Then I just take off for every single one you use. I'm not gonna be like, okay guys, let's stop class. Like, oh, you've used 3 bathrooms, blah blah blah. No. In college, they don't keep track of you.
Each one we
So why do
use.
they
But the reason I keep track of you now is because you will come back, complain to me, oh, blah blah blah, I missed what's going on in lesson. Yeah, because you were gone for like 10 minutes. Sorry you missed the lesson. Like, cool, maybe go to the bathroom between classes.
Wait, so if we use the bathroom pass, we're getting deducted points right now?
Yeah. You get 3 per semester, that's
So you're
it.
saying we get 3 and then if it's like
Every single one after 3, I deduct.
If you said one of the 3, then we get deducted points.
Man, if only we knew how to read our syllabus, like, man, it was all spelled out. But how do you make up participation points? You do problems on the board. When we have review days.
We don't do problems on the board.
Okay.
Review days.
Review days, what are they? You just ask what they are?
Today when you reviewed for tests and quizzes
How do you get points for that?
on the board.
We don't do those
We never did that.
I can't like
We have.
compensate for my bladder like I want to.
Okay, Jenna, we can talk about that after class. Like, we can talk one-on-one.
Okay,
Okay.
I will.
Not necessary.
this conversation with Mr. Your backpack.
Like, if you get to class and you're like, I have 3 more minutes before class starts, like, you get here, drop your stuff off, cool. You can be like, 1-2 minutes after, the tardy, because you came here, you have your stuff, you, like, checked in with me, cool. But if you, like, stroll in, 3 minutes after tardy, okay, where you been? What are you doing? Or, like, literally just leaving in the middle of class. Like, whatever, it's fine if you, like, go to the bathroom, whatever, but, I just keep track of it. I don't even say anything. So, today there's been at least 5 people out in the bathroom.
After lunch, rolling.
Because, oh my god, because I have no time to pee with the 45-minute lunch break. Like, it's so fast. Like, I have to eat my grain of rice one at a time, and it takes the whole 45 minutes. Cool.
Yeah, and then 20 minutes later.
Digestion.
I'm sure Nathan loves this conversation, so let's keep going with the lesson. Let's keep going with the lesson. He's not here right now, and I'm screencasting for him. So he's going to have to watch this whole thing and listen to this. Alright, so end of conversation. If you want to talk with me about this, see me one-on-one. I would love to talk to you about your bathroom passes. And in specifically, I'd love to talk to you guys one-on-one about your participation in class. That would be great. I would look forward to it. Please, search me out and we can have a conversation about your grade. I would love it. I would love it. Let's do it. Make one-on-one appointments. I will walk you through exactly why your grade is the way it is. All right, so let's keep going. -4 times the second equation. -4 times the second equation. So -4y plus 16z equals 20. How did I get these numbers? Oh my god, look at equation 2. I just multiplied every single thing by -4. Now I'm going to add equation 3. 4y minus 2z equals -6. I will add these, the y's go away. I have 14z equals 14. In the previous page, what was the 4th thing we had to do though?
The variable by itself.
Let's see. So we get rid of the y term, we did that. But number 4 says make sure the leading coefficients of each equation are 1. Let's come back down here. I'm going to divide each one of these by 14 before I solve. Because then my coefficient will be 1. Technically, I'm not going to write it because I do it in the last part. Equals 7y minus 4z equals -5. And lastly, z equals 1. This is my triangle. Check it out, I made a triangle.
No way.
Solve.
So pretty. So it looks like a Pythagorean theorem.
It's like Queen Bird's Eye.
What?
It's a triangle. Okay, let's keep going. So, I have a triangle. Step 1 done. Step 2, solve. Okay, so, let's go through how to do this.
It looks like Utah.
Good evening, buddy.
No, it looks like, oh my god, that looks like Nevada. My triangle looks like Nevada.
That's
I
good?
don't even know what Nevada looks like.
That's good.
Because I've seen
So,
a map.
to solve, what we're going to do, we're going to start with equation 3. Start with equation 3. I have equation 3, z equals 1. Then, I'm going to go to equation 2, plugging in my z. So, equation 2 is y minus 4 times z equals -5. So, y minus 4 equals -5. Y is equal to, let's say I have to add 4 on both sides. to show you the steps. Y equals -1. Okay, then I'm going to go to equation 1, plugging in my values I have so far. X minus y, which is -1, minus z, which is 1, equals 7. X plus 1 minus 1 equals 7. X equals 7. You guys ready for this one? So, solution. What? I'm not doing anything. So, before you guys ask me, what's the answer? Here's our solution. X comma y comma z. This is 7 comma -1 comma 1. That is it. Whole page of work just for this.
Is there a little faster way to do that?
This is the Gaussian elimination method.
Is there a better way?
There definitely is a better way.
Yeah, I mean, it is what it is. Yeah.
Let's do the wrong answer. Let's do this.
All right, let's keep going.
Yeah.
If you can silently stretch while people finish writing.
I have a question. For equation 1, why are you allowed to replace? Why are you allowed to put in an? Oh, I get it. You solve the first ones and then you work.
We got it.
That's smart. Well, we thought of this.
Genius on their time.
Gauss. It was Mr. Gauss. Mr. Gauss. All right. So let's. Who needs more time to write this down? Needs more time to write this down. Tulu. The screencast will be uploaded. It's just gonna take like 2 hours for it to upload. This is gonna be great. So you're gonna listen.
I actually like
Are we done writing? We're done writing. Okay. Yeah. Well, it's just annoying because then I have to. If I turn off my computer to like go home yesterday, it was almost done uploading. It failed, and then I had to wake up this morning, redo it. It's just annoying because I have to like sit my computer down for like 2 hours. It's fine though. It's alright. It's better than me having to do my own screencast. When solving multivariable linear systems, the variables remain untouched.
Throughout accident.
Therefore, I'll wait till we're quiet.
Guys, Sarah.
Are you paying attention? What are you doing?
Me?
Yep. Turn, face the front. Okay. Don't bother other people. Therefore, the system can also be solved using a matrix which lists the coefficients in constant terms only. So we went through this whole like Gaussian elimination with these systems. What's wrong?
You can do all that easily.
Yay, matrices.
I love learning the Gaussian.
Because sometimes, you know, like, okay, imagine your life. If it was rainbows, butterflies, and unicorns every day, you wouldn't appreciate it. But if you had a couple rainy days, it makes you really appreciate the rainbows better. Now you'll really appreciate matrices. After doing this hellish problem that was a whole page.
Like the way you think.
All right,
That'd be really true.
there you go. Life skills, life 101.
Will you ask us to solve with the Gaussian method?
I'm sorry, I don't know. Therefore, the system can also be solved using a matrix which lists the coefficients in constant terms only. So we can just list the coefficients in constant terms. Such a matrix is called an augmented matrix. Literally, yay, augmented matrices. So guess what? The x's are all the first, y's, z's, normal numbers. And then we can have the coefficient matrix. Well, that's only the coefficients. Notice that dotted line. That means, oh, there was an equal sign. So everything on the left side of the matrix is equal to the right side. Okay. So what? The dotted line is showing that there was an equal sign in between them. So it's showing you which side of the equation it was on. Yep. All right, elementary row operations. Each of the following row operations produces an equivalent augmented matrix. Interchanging any two rows, so literally you can take the first row and second row and switch them. It doesn't matter the order, it still works. You can multiply one row by a non-zero number. Wait, this is just like when we were doing system of equations, where we multiplied everything by a number. Like as long as you do it to one side, do it to the other, we're okay. Same here. As long as you multiply the whole row by that one number, we're still okay, because I'm still taking account both sides of the equation. And adding a multiple of one row to another. Literally, it's like system of equations. It's just instead of having to write x, y, z, and blah, 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 it's a much more condensed, compact form. A series of row operations are applied to a matrix with the purpose of transforming it into row echelon form. A matrix is in a row echelon form if the following conditions are met. Rows consisting entirely of zeros, if any, appear at the bottom of the matrix. The first non-zero entry in a row is 1, called the leading one, which makes sense. If it was the coefficient, we want ones as coefficients as the first numbers. For 2 successive rows with non-zero entries, the leading one in the higher row is further to the left than the leading in the bottom row. Okay, let's see if these are in row echelon form. How about A? Is this in row echelon form?
Yeah, because it's a triangle.
It's a triangle. The coefficients are 1.
How is that a triangle?
Because it goes from 2 to 1. So
That's the triangle.
it condenses.
1, 2.
Because if I color only the numbers, it's a triangle. What about B?
No.
No,
Why?
because first of all, they're not all ones, and they don't. Yeah, they're not all the leading coefficients.
Those must be at the bottom.
Yeah.
The row of zeros must be at the bottom because it has to go in order. If you have any rows of zeros, they must be at the bottom of the matrix. That was the first thing we talked about up here. Rows consisting of any zeros, entirely of zeros, must be at the bottom. And
Yes.
what?
Oh no, that's not right.
Nope. What about C?
Yes.
Yep. Because I have coefficients of 1, leading coefficients of 1. It's literally a triangle, and then the row of zeros is at the bottom. So, I mean, it kind of looks like this guy up here. We're at a triangle, and then I have a row of matrices at the bottom, a row of zeros at the bottom of the matrix. Cool. Okay. So here are some tips and tricks. Start with the entry at the bottom left corner. A31. So wait, what does A31 mean?
Row 3, column 1.
Exactly. Row 3, column 1. So literally that's that one. It's the bottom left corner. Second, eliminate A21. So we'll start with the bottom left corner. We'll eliminate the one that's on top of that. Then we'll eliminate the one that's to the side of that. So what we're going to be doing is starting with the bottom left corner, eliminating the one that's on top of it, eliminating the one that's on right of it, and then guess what? I'll have a triangle form. That's our goal. Okay. So let's do example 3. I think we have enough time we can do it. Okay, solve the system of equations for example 1 using an augmented matrix. Use the same procedures to put the matrix in row echelon form. Perfect. Okay, so we're going to be doing the same thing. We're going to be getting the same answers. It's just difference is we're doing rows with matrices. This is R3, R2, R1. Here that just means rows because I'm not having equations. Okay, so I'm going to make an augmented matrix first. So I'm going to, let's see. So 5, -5, -5, 35. -1, 2, -3, -12, 3, -2, 7, and 30. Okay, so far so good? All right, from the previous page, well, I should probably write what our goals are at the top. Number 1, the first thing we're going to do is actually write the system as an augmented matrix. Did we already do that? Check that off. And the second thing is perform row operations to write in row echelon form. Perform row operations. To write in row echelon form. Okay, we're done with number 1. Heck yeah. Turn to the neighbor next to you and high five him. Look at you, already half done with the problem.
Hell yeah.
I don't think. Okay. Yeah. Shanishi has both your hands down. Okay.
Shania.
Okay, cool.
She missed double. Oh, she missed Jonah. Jonah, high five someone.
Cool. What?
He's back now.
What'd you say? Okay. Appreciate it. Appreciate it. All right.
He's under the weather.
Not over it, under it.
He's feeling it.
Okay, so first thing we want to do. First thing we want to do is make this 0. So make this 0. Huh? I want to make it 0. How do I actually make it 0 though?
Row by 0.
No.
Minus everything by
How? What? Okay. Can I like add another row to it, or add a multiple of another row?
What?
Replace
Multiply
row 3 with what the heck? Oh, I get it. Oh my god.
Oh!
Jonah, why don't you speak up?
I heard it.
All right. Oh yeah, Friday's under the weather.
As long as it's under the I don't get it.
Okay, whatever.
It's the same thing.
So I'm going to yeah, I'm going to multiply the second row by 3, add it to the third row. What will I get?
Wait, can we?
Yeah.
Is that getting rid of one of the fingers?
Yeah. I get rid of the bottom left corner one.
Slow down, move too fast.
Shh.
So it's the same thing as before, the 3E. Wait, why did you start from the middle?
I don't know.
That was so weird.
What?
You started from the middle row, and then you went down and then you went up.
No.
Whatever.
Did you start at the bottom?
I start at the bottom. Okay.
Can you show us the steps of sorting?
You're not.
You're not.
Can you make a step?
We
So-
have to memorize these steps. That's gonna be on my test.
Yes and yes. All right.
That's funny.
How did you get from -2 to 3? I get it.
So, okay. So I'll make an aside. I'll make an aside here. Okay. So what this looks like is if I multiply. Oh wait. Oh wait. I'm gonna explain it. I'm just waiting for people to be quiet. Okay. So how did I go from the left matrix to the right one? So I take the second row, multiply by 3. So -3, 6, -9, -36. And I'll be adding the row underneath it. So row 3. So I have 3, -2, 7, and 30. When I add them, I get 0, 4, -2, -6. And so that's what I used to replace up here.
Reminds me of like some. That's what I was thinking.
Cool. Okay. It's nothing like it, but okay. Cool.
I know, because you're like smart enough to like differentiate two, and you're like, what? No, they're completely different for us.
It's not at all what I was like.
No, for us,
Okay.
we're so confused that we try to like make it similar.
Wait, I have a question.
Yep.
And then when you combine them, you just like revert R2 back to its original form?
Yep. Because I'm only replacing the third row. Because I added 3 times the second row to the third one. I didn't touch the second one. I like used it. Like I took the numbers, multiplied by 3, and added them to the third, but I didn't actually change the second row at all. All right. So now I want to make yes.
I see why you replace R3 with 3R2 plus R3, but why are you allowed to do that?
Because
Is that against algebra rules?
nope, it's not. Let's see. So elementary row operations. Each of the following produces an equivalent augmented matrix. Interchanging into rows. Multiplying one row by a non-zero number, I could multiply second row by 3. Then adding a multiple of one row to another. So I multiplied row 2 by 3, and then I took that whole thing and added it to row 3. So I can add a multiple of one row to another, multiple of the second row to the third row. I can do that. Yep. These are like the things you're allowed to do. Like I gave you the list for the systems, I gave you a list for this one. What? Okay, so I want to make, so I'm trying to color code a little better. Make into a 1. Okay, cool. How do I actually make it into a 1?
Divide.
Yep.
Can you just divide all of them by 5? That whole row.
Yeah, more or less. Replace R1
Aren't you gonna do one?
with 1/5 R1. So literally multiplying every single one by a fifth.
5, 4, 3, 2,
So 1, -1, -1. Okay, cool. So now that I have that done, are we done writing down?
No.
Okay.
Are we done test on this yet?
So, if you look at the lesson plan I gave you, on the 14th,
March 14th.
yep,
Pi
it's your
Day.
Pi Day.
Pi Day test for us.
Wait, on Pi Day in 2015, we were like ecstatic.
Yep,
Why?
Because it was 3.1415. And that's like actually.
No way, that's cray
You make the
cray.
best part of your life.
of course.
What kind of pie
Yep,
should I bring?
at 9:26, we really celebrated.
And at 5:35
It's your birthday too?
Yep, I'm born on Pi Day.
Really?
Yep, it's destiny. It's destiny.
Wait, are you serious?
Destiny's Child.
Yeah, that's why I brought you pie on my birthday on October 5th, because my birthday is on March 14th.
Wait, October 5th?
Sarcasm.
That's her birthday, Sarah.
I thought her birthday was Pi Day.
I don't remember. I have short-term memory. I don't even remember what happened last week.
I'm short-term memory.
Her birthday is October 5th.
So why did she say her birthday was
It was a joke.
I don't know.
Sorry.
Alright.
just made a joke that her birthday was on Friday because Jenna randomly asked if her birthday was on Friday.
Of course it is. Yeah, I'm a math teacher. It's a requirement. Okay.
Why is it?
So, guess what I'm gonna do? I'm gonna make the -1 0. How do I get rid of this -1?
Just add the first 2 rows.
Who said this?
I know.
Air 5. That's you're on the ball. See, there's another way to get participation points. Be on the ball.
I like what? You get participation points for
Yeah, for paying attention and like, yeah, imagine getting participation points for paying attention in class and knowing what we're doing.
That's what we're gonna say.
All right, I'm good. All right. Yeah, let's do this one and then we'll be done for the day. Okay, so what I want to do is replace E2 with E1 plus E2. Sorry.
Oh, it's time to get this.
Replace row 2 with R1 plus R2. So what that looks like.
Look at you.
Okay. So I just need to copy this over.
Wait, when is the test?
Pi Day. Sarah.
Is it actually good?
If only I made a document that like detailed this and like if I ever
You're recording it.
that'd be yeah. Well, if only I would, like make a document that describes when things are, like homeworks and quizzes and stuff like that. That would be great. That would be so nice of me. That's a joke. That is the joke. That's the whole joke.
I know I'm adding on.
People ask me when the test is. I wonder when it is. Probably when I told you it was. Okay. Cool.
Oh my god.
Okay. Cool. So I copied this over. If I add these together, oops.
You got 4.
Oops, I copied the wrong ones. No. All right, well, we'll stop. Whatever. What was the first row? Will you read it to me?
1, -1, -1,
1, -1, -1, 7.
Yeah.
So 0, 1, -4, and -5.
Emma is legend.
Yeah. Cool. That is what it is.
I see Emma as legend. I like Emma
Okay.
legends. I get wait. I'm not
So this will be, yeah, we're going to stop here. Yeah, we're going to stop here. As soon as I rewrite the matrix, so 1, -1, 1, 7. 0, 1, -4, -5. 0, no, 4, -2, -6. But we're really close. Because the only thing we need to do is fix the bottom row. I need to make that 4 a 0 and then fix need to make this a 0.
You make the -2. No, you didn't make the -2
Oh.
1, I thought.
Yep, sorry. Make this a 0. And then get rid of the -2 coefficient. Cool. So we'll finish this tomorrow.